Hello everyone. Today let's discuss about Floyd-Warshall's algorithm. So I'll just give FWA Floyd-Warshall algorithm. So let's discuss the approach step by step first. So basically Floyd-Warshall algorithm is an all-pairs shortest path algorithm for the graph. So it is used to find the shortest path between the pairs, right? So that is the reason we'll be making use of the Floyd-Warshall algorithm. So basically what's the idea here? It is used to find the shortest path. So let me write here. Shortest path between pairs. So this is first step. So let's understand the basic idea behind this one. So the idea is to repeatedly consider whether a path through the intermediate vertex gives a shorter route between the two vertices than any previously known path. So if we have already got the shortest path between the two vertices, and we know the path, and from the center vertex, if we are able to find the path, whether we are able to find the shortest path between the two vertices, in this case, the Floyd-Warshall algorithm will be very handy. So this is why this algorithm will be mainly used. So basically this is the idea behind Floyd-Warshall algorithm. So third step is, so for every pair I and j, so suppose let's consider this one, I and j are the pairs, nothing but pair of nodes, this one I and j. So for every pair of nodes I and j, we will be checking if going through an intermediate node k gives us the shortest path. If yes, then we will update the shortest path. So for every pair, this one I and k, for every pair of nodes I and k, we will be checking by going through an intermediate node k here. Intermediate node will be k here. If it gives a shortest path, then we will update the shortest path. So if it gives the shortest path, then we will be updating the shortest path. I'll just give SP over here. So next, final step. What will be the final step here? So we will continue this process. The process is repeated for each node that is being considered as an intermediate node. So we'll be considering the node as intermediate node, and we'll be checking the for this one shortest path for all the nodes. That's what we will be doing using the Floyd-Warshall algorithm. So continue process. I'll just give CP. So here, this is the approach that we will be going with for this algorithm. Let's write the code and try to understand with the example, and finally we will discuss about the time complexity and the space complexity. So let me give here function Floyd-Warshall of let me consider the parameter graph. So initially, step 1, as we had discussed, n will represent the number of vertices in the graph. Let's consider n. I'll just consider here graph dot length. So next step is we will create the distance matrix initialized with the graph's value. Nothing but here I'll be making use of the dist for this one. Distance dist will be making use of, will store the shortest distance between every pair of nodes. I can just give in this way. Let dist equals array dot from. So here let me give length of n. Let's consider length of n. So here let me randomly take the underscore here. I. This one I'll just consider in this way. I can write in this way, right? So just give me a second here. Array dot from I'll just make use of here. Again, let me consider length n again here. So let me give here. Did I do something? No, right? So I and j I have to consider. I already have considered I. Then here let me consider j. So finally, this has to be 2D matrix, right? Yeah, this has to be 2D array representing the adjacency matrix, right? So we are making use of the 2D array. That is the reason we are going like this. So this has to be graph of ij. So let me write this one as graph of I and j. I hope this is clear. So next step, what we will be doing? Step 3, as we had discussed, we will process each vertex as intermediate vertex. So we will consider each vertex sometime. At some time, we'll be considering each vertex as the intermediate node, and we will try to find this one shortest path between all other this one vertex or the node. That's why we'll be making use of this algorithm, right? So let's start processing each vertex as an intermediate vertex. So for this has to be let k equals 0, k less than n. Let me increment the k. Next step is k is the intermediate vertex, right? As we had discussed. So we will be checking the paths through. So how can I write this one? Let me consider this one. Let I equals 0, I less than n, I plus. This is nothing but I is the starting vertex, right? So next, j will be the destination vertex. So we'll be considering again one more loop. Here this will be j equals 0, j less than n again. This will be j plus plus. So I hope this is clear till here. So I is nothing but the starting vertex or the start vertex or the starting node. J is nothing but the destination vertex or destination node. So the next step is we have to update the shortest path if a shorter one is found, right? So if we find the shortest path, we have to update the shortest path. So here, let me make use of if condition. We have considered dist, if you remember. So dist of ij, as this is, we are making use of the 2D array, is greater than distance of, this has to be I, k plus dist of k and j we have considered, right? So this is correct. If the distance from I to j via k is shorter, then we have to this one update the dist of I and j, right? So that is what we'll be doing here. Distance of I and j equals dist of I k plus dist of k and j here. So here, I hope this is correct in here. Let's see. Final step is we will return the matrix of shortest distances between all the pairs. So here I have to just return the dist, right? We will be having the this one result in the dist. So let me return the dist. So this is it for the code. Next, let's check this with the example. I'll just take here this example. Let me give graph this one, construct graph itself. What we have given here, we have considered the adjacency matrix representation of the graph. So here we have considered infinity. Infinity means there is no direct edge between the nodes. You don't have to worry about that. Infinity just means that there is no direct direct edge between the nodes. Also, the diagonal here is, you can observe the diagonal is 0. You can clearly observe here first one, second one, third one, finally fourth one and fifth one. Here the diagonal is 0 because we have the shortest distance. So the diagonal is this one, 0. From a node to itself is always 0. So we have to keep in mind, from a node to itself is always 0. Let's call after this step, what we will do, let's call the Floyd-Warshall function to compute the shortest paths. So I can just consider in this way. Shortest paths, I'll just give Floyd-Warshall is the function name that we have to, and the parameter is graph. So finally, after calling the Floyd-Warshall function to compute the shortest path, we have to print the shortest path matrix as well, right? So for that, I'll be making use of console log here. Let me make use of backticks here. Shortest path matrix. So I can simply take here this one itself. What do we call? Single inverted comma itself instead of backtick here. we're not making use of template literals, right? So here I can give here shortest paths. I'll just make use of for each. Here single row. Let's consider this one. Let's log every single row here. Console log of. Let me give row. So here, just give me a second. So let's check this one. Let me run this one. So here we have the shortest path. So 0, 3, infinity, infinity, 2, 0, infinity, infinity. So this one we have got, right? So we have got the shortest path. So as I've said, while I just I gave this one graph equals this one, we have the shortest path. That is the reason the diagonal is 0. So we have the shortest path here, 0, 3, infinity, infinity. So this one you can clearly see 2, 0, 0, 3, 7, 6, 0, 1, 3 here, 6, 5. This one, this works absolutely correct. So what will be the time complexity and the space complexity? The time complexity would be big O of v cube or n cube, nothing but n to the power of 3 or v to the power of 3 vertices, right? V to the power of 3, where v is the number of vertices. This is because we have 3 nested loops, right? If you have observed here, if you have observed the code here, we have 3 nested loops here, right? So that is the reason this one, what do we call? The time complexity would be big of v to the power of 3 or n to the power of 3 if we are considering as node. The space complexity would be v to the power of 2 or n to the power of 2. Why? Because we are storing the distance matrix dist of size v into v. Nothing but v into v is nothing but v to the power of, v square or v to the power of 2. So here time complexity would be v to the power of 3 here, and also space complexity would be big O of v to the power of 2 here. So I hope this is clear. So yeah, this is it. This works absolutely correct. This is it. Thanks for watching, guys.